So continuing on with chapter 6, we're going to look at adding and subtracting rationals. No lie, this is probably the most difficult section of all of them. People tend to struggle with adding and subtracting fractions. So the way I'm going to try and show you is going back to basics like this one, and showing you how it applies to how you can build it up for any type of ration. So very first thing, you need to remember how to do a problem like this one. You know that to add or subtract fractions, you have to get a common denominator. And if you've been following the way that I've recommended you try doing that, is to not just think about it, to not try and get the perfect common denominator right away from the beginning. Instead, think about how you can factor them apart, see what makes up the denominator, go from there on making them common. So before anything else, I would start figuring out how I can pull apart or how I can factor apart the denominators here to see what makes them up. So in each one of these cases, I factor apart 15, I factor apart 12, and I see what that gets me. Whenever you do this, it should be a little bit more obvious about what it's going to take to make them common. For instance, they already both have 3's. That's good. However, this one has a 5, this one does not, which means to start making them common, you have to multiply by the factors they're missing. Same thing for the other side. This thing has a 4 and this one does not. You need to multiply by that. Whenever you get done multiplying by what they're missing, double check, make sure that they agree now. So they both have 3's, they both have 5's, they both have 4's. So the denominators are the same. I don't know what the number is, but I know that it has to be common. So from here, I guess the extra part of it is that now you have to multiply everything back together. So you have to multiply the top pieces, the bottom pieces, everything to get 32 over, think about this, 3 times 5 is 15, 15 times 4 is 60. And the other one, minus 25 over 60. Now I didn't have to think about the denominator on the other one because I knew it had to be 60 because it has all the same factors, so it has to multiply up to the same number. That's kind of the benefit of doing it this way. After you have common denominators, it should be on the downhill slide from there. All you have to do is figure out how they subtract what you're going to get here and come up with your final answer. So if you think about it, 32 minus 25 is going to give you 7, and you keep the common denominator, so 7 over 60. Try and simplify it if you can. In this case we can't, so this is literally the final answer. But before you circle it, always think about simplifying. So I freely admit there are a lot of steps that are going to be going into a single problem here. You have to be really good at factoring, you have to be pretty darn good at multiplying, adding, taking care of negatives, and simplifying. I mean, there's a lot going on into the problem here. So try and take it pretty slow, careful, write out all the steps, don't try and skip stuff and do it in your head, and it should work out. If you're the type of person that likes having a list, kind of a list of things to go through here, here's what I've got for you. The very first thing is to figure out what the common denominator is going to be. That's where you factor all the denominators apart. You have to multiply by entire factors, so not just adding a number, you can't do that, you have to multiply by an entire piece until you've made all the denominators common. From there, you have to at least multiply the tops back out so that you can add and subtract them, and then simplify your final answer. Okay, so there's a neat little list, maybe kind of shorter than what it might need to be, but get you started. So the first round of examples I've got here, these are going to be the easy case. We are going to get into the more difficult ones, the ones you're actually going to be seeing, but this is a good place to start. It'll get you used to the ideas. So let's think about part A. We're trying to add xy over 4 plus 3xy over 8. I'm hopeful that whenever you look at the numbers, it's kind of obvious that you have to multiply by 2, but if I'm writing out all the steps, just to keep going with that idea of writing everything out, you want to try and factor all of the denominators apart. Now, there's no reason to factor it. A number like 4, if you already know that there's going to be a 4 over here, so you can kind of cut some time out that way. You could take it all down to primes, it doesn't matter. Either way, you're going to come up to the same common denominator. The way I'm showing you here is just a little bit faster. So you do multiply the first one by 2. Make sure you're doing this top and bottom because you have to keep your fraction balanced. Gives you 2xy over 8 plus 3xy over 8. So that was multiplying everything back together. Now you focus on the tops. You want to try and add them together. 2xy and 3xy gives you 5xy. The common denominator stays the same, so whenever you're adding, once you've found that common denominator, just keep it for the rest of the problem. Think about trying to simplify, and if it doesn't, you're done. Okay? Now, part B here, we're going to step up the denominator here. You have to worry more about the factors, because now we have actual polynomials in the denominator. So whenever I think about factoring, now I have to go for the rules like GCF, grouping, trinomials, difference of two squares. You got to think about those rules when you factor them apart. So if you notice a GCF, that needs to be pulled apart. Don't really care about the tops too much at this point, so I'm just kind of copying those over, and I'm worrying more about the denominators. One habit that I try to get into is whenever I have a factor, I put it in parentheses. I wasn't really doing that with the numbers because it starts to look a little bit awkward, but whenever you start having plus or minus signs, so you've got x plus 2 or x minus 4 or something like that, put that factor in parentheses so you think about it as being one unit or one thing by itself. Okay, and then you look at the problem and you figure out how you are going to make common denominators. You got to multiply by 5 so that they match. And so this problem is going to become x plus 1 over 5 times x plus 2 plus 15x plus 10 over 5 times x plus 2. You can save yourself a little bit of effort by not multiplying the bottoms together again. You don't need to. If you just have all the separate factors listed out, that's good enough. And then put the tops together. So add like terms to get 16x plus 11 over your 5 times x plus 2. So really the only way you're going to simplify the actual problems we're working on is if you can factor the top. And if you can't, then you're done. That's all you can do on a problem. Okay? So those we're worried about coming up with common denominators, these are going to be getting used to a minus sign. So if you notice on both parts C and D, the denominators are already done, right? They're already common between them. So the worry instead is what to do when you are subtracting. And you have to be really careful with this. This is a mistake I see all over the place whenever I'm grading papers. You have to make sure that this negative sign is going to apply to everything on the fraction that comes after it. So you have to distribute that negative sign through. If I'm writing out all the steps, which I'll be honest, I'm not going to always because it takes too much time, but the way you should think about it is putting them together like this. Since the denominators are common, this is what you're really doing. You're putting the tops together and you're trying to, in this case, subtract them. So you keep the minus sign between them, and this is what you should see to visualize, to remember, to notice that you have to distribute it through. Okay? That negative sign has to apply to everything. So you will get on top 5x plus 1 minus 4x plus 2 over your common denominator of x minus 3. And then you go about combining like terms, putting stuff together, until you get your final answer. And notice here that I cannot simplify because they are not the exact same factors. So you cannot cancel them, you can't factor anything out to make them match. This is it, that's where you're done. Okay? So even if it looks more complicated and you have 3 separate pieces, all the ideas are the same. So again, because we're just getting in the intro stuff here, I'm going to write out all the steps. I won't do this in general, but what's going on here is because all the denominators match, you're trying to put together all the tops. Whether you're adding or subtracting or whatever, you're just trying to put all the tops together. So I put them in parentheses, that way if there happens to be a negative sign, I see that I have to distribute that, I don't miss that part. and I put it all over the common denominator because they were all x minus 7s. I don't have to worry about it, I can just put them together and go with it. So this problem is actually asking me to take 3x plus 2 minus 5x minus 2 plus 2x plus 1 all over x minus 7. And so if you think about combining together like terms and seeing what you're going to get here, let's start with the x's. We've got 3x minus 5x is negative 2x, plus 2x is nothing, they're all gone. Then I look at the numbers, I have 2 minus 2 is nothing, plus 1 is 1. So all told here, I'm going to have 1 over x minus 7. Okay, and those are the basic problems. We'll come back in the next video, we'll look at some of the more complex adding and subtracting.